Okay, today we're talking about proportional relationships. The objective, I will learn to use ratios and scale drawings to make indirect measurements and solve problems. We're going to kind of define what indirect measurement means, and that's simply any method that uses formulas, similar figures, and or proportions to measure an object. So we kind of been doing this already, but we're going to focus a little more on, word problem type questions. And here is the first one. Tyler wants to find the height of a telephone pole. He measured the pole shadow and his own shadow, then made a diagram. What's the height of the pole? All right, so the first thing we need to do is since it's written in feet and inches, we kind of have to convert these into either feet or inches. I'm going to use inches because it's a little bit easier to work with. And remember, each foot is 12 inches, so I need to multiply 5 times 12 and add 9. So his height comes out to 69 inches. Okay. And if I look at his shadow, that's going to be 7 times 12 plus 8, which would come out to be 92 inches. And then I need to take the 38 times 12 plus 4, and that comes out to be 460 inches. And these are going to be the numbers that we use to set up the proportion. So nothing too difficult here. We're going to do h for height over 69 is the same thing as 460 over 92. All right, using our cross products, 92h is going to be equal to 31740 divided by 92. The height comes out to be 345, but that's inches. All right, we're going to need to convert that into feet. So we're going to take the 345 and divide by 12, and we end up getting 28.75. All right, so I need to kind of convert this 0.75 into inches, so that's 28 feet. And I want to figure out what this 0.75 is. So I'm going to take that and multiply by 12, which gives me 9. So it's 28 feet 9 inches. That's the actual height. All right, this next problem very similar. It's just we're going to use meters this time, so we don't have to mess with inches. We would say x is to 21 as 56 is to 24. Cross multiplying, we get 24x equals 1176. Divide by 24. X is going to be 49 meters. All right, next example. Stephanie stands 2 feet from a lamppost. Her shadow is 3 feet long. If Stephanie's 5 feet tall, how tall is the lamppost? So let's draw it where here's Stephanie. And she's 5 feet tall. Her shadow is 3 feet. Okay, she's 2 feet away from the lamppost. We want to know how tall she is, or how tall the lamppost is. There's my lamppost. So let's do a proportion. We're going to say x is to 5 as 5 is to 3, because we'd have to add from here to here. That gives me the 5 feet total. Cross product, we get 3x is equal to 25. divided by 3. X is going to be 8.3, repeating. And that's just in feet. If I want to get these 0.3 in inches, what I'm going to have to do is convert this, kind of like what we did with the 0.75 earlier in example 1. I'm going to take this 0.3 and multiply by 12. Right. This 0.3 with the line over it, that's 1/3. So 1/3 times 12 is going to give me 4. So this is 8 feet 4 inches. That would be the height of the pole. Next example. I'm going to leave that up to you. You guys can work this one out and check with me if you want to see if you did it right. Alright, example 5, I am going to do this one with you because it's a little bit different. We haven't seen one like this where there's a mirror on the ground and 8 feet from Ricky. So if Ricky is 8 feet away from that, so here's Ricky. Alright, and that mirror is 19 feet away from a flagpole. Okay, Ricky is 6 feet tall. So his line of sight is going to create this kind of a right triangle going this way. And that mirror would let him see this direction towards the flagpole. Alright, let's see, the height of the flagpole is what we're looking for. So there's kind of my picture. This would kind of form right angles here. So I would say the height, h over 6, is going to equal 19 over 8. Cross multiplying 8h is going to be equal to 114. Right, if I divide by 8, that's going to give me 14.25. So again, the height is equal to 14 feet. And I want to take that 0.25 multiplied by 12, right, and that ends up giving me 3 inches. So the height of the flagpole is 14 feet 3 inches. All right, the next thing we need to talk about is this kind of relationship that happens with the similarity ratio, perimeter, and area. This proportional perimeters and areas theorem says that if the similarity ratio of two similar figures is A over B, then the perimeter ratio is also going to be A over B. But what happens with the areas, that ends up being A squared over B squared. Right? So if I have some ratio A over B, for the perimeter of the shape, it's going to be the same thing. It's going to be A over B. But when we get to area, we have to square the A and the B. Right, so here is an example that we're going to look at. And on this should actually read 48 feet squared. And the distance from R to S should actually be 16 feet. Okay, so the ratio of the perimeter, P, is going to be 16 over 20. And then we're going to set that over 36 over P. And P would be the perimeter. So I need to figure out what the perimeter is of this figure triangle UVW. So cross multiplying gives me 16P is equal to 20 times 36, which is going to be 720. Right, and if I divide by 16, the perimeter comes out to be 45 feet. Right, and then for the area, we're going to have to do 16 squared over 20 squared, and then 48 over A. For 16 squared, that comes out to be 256. 20 squared would be 400. 48 over A. So we do 256A is equal to 48 times 400, which is 19200, divide by 256. A is going to be equal to 75 feet squared.